Alright, today is day 76 for Algebra 2. Today we're going to extend polynomial identities. Here's your objective. I can extend polynomial identities to complex numbers. Alright, so we're talking about polynomial identities in math. An identity is when you have the same thing but presented differently. Think of yourself. Think of your name in your brain. Okay, don't say it out loud. What's your name in your brain? Okay, now think about what's your screen name if you have a Facebook. What's your screen name on Facebook? Is it the same thing or is it different? Raise your hand if it's exactly the same as your identity. Okay, raise your hand if yours is different or slightly different than your identity. Maybe you're just using your first name. Does that change who you are even though your Facebook screen name is a little differently? Really? It changes who you are? Oh, okay. What about Instagram? Raise your hand if your Instagram screen name is different than your real name. Does it change who you are as a person even though it's a different screen name? No. What about your Twitter handle? Raise your hand if you have the Twitter handle and it's different than your actual real name. Does it change who you are and your identity? No. What about your Snapchat handle or name? Does that change who you are? No. Okay. Does that make sense? You have a lot of different names, but does it change who you are as a person? No. Okay, so that's the same thing with math. We have identities. Okay, so for example, this one we're really used to is in this. This is a perfect square trinomial. Remember, complete the square. This becomes x plus 2 squared, right? Do you all agree with that?
Yeah.
We're all used to seeing this.
Easy peasy.
This is the same as this. Easy peasy, right? Okay. Lemon squeezy. That's right. So what if we had x squared plus 9? What does that turn into?
It's going to be x negative 3 squared.
It's not x plus 3 and x minus 3, right? Because that only works when it's x squared minus 9. Right? This is difference of squares. This turns into x plus 3 and x minus 3. Okay? Does that make sense right now? Yes? Okay. Good. So, we need to figure out what does this turn into. We know that the goal for today is turning this into a factor, okay? We can't factor this right now. I'm going to show you how to factor it, okay? Let me show you a different way to look at it, okay? Ready? Let's pretend this was a solve problem and this was x squared plus 9 is equal to 0. How would you solve this? Well, you could subtract 9 on both sides and then you take a square root and you get x is equal to plus or minus square root of negative 9. So then you get two answers. X is equal to positive 3i and x is equal to negative 3i. Yes?
Yeah.
Yes? Okay, good. So, what if I were to subtract 3i on both sides? And I was like, okay, x minus 3i is equal to 0. And x plus 3i is equal to 0. Would you agree with what just happened here?
Yes.
Is it making sense? Okay, so then when I look at x minus 3 and x plus 3, let's look at this original problem right here. Right here. You see this? Wouldn't this turn into x plus 3i times x minus 3i? Does this logic make sense? Okay, really quick. Someone who's the most confident explain to the rest of the group, how did I turn x squared plus 9 into this? Okay, ready, set, go. Some people are like, how does it x plus 3i and x minus 3i? Well, look over here. How did I know this was x plus 3 and x minus 3? How did you know to split it like this?
Because I knew that 3 times negative 3 equals negative 9, but 3 plus negative 3 is 0.
Good. It's a difference of squares problem. Excellent. That was a good explanation. Okay? And this is how we did it, right? What's the square root of x squared? X. Good. What's the square root of 9? 3. And there's a negative sign, so I know it's going to be plus and minus. Does that make sense?
Yeah.
What about this one? Can I take a square root of x squared?
Yeah.
Yeah, it's x, right? But what's the square root of negative 9? Can we do that? No, we can't. Now, here's another way to look at it. I'm going to add another problem underneath. Isn't x squared minus a negative 9 the same thing?
Yeah.
Do y'all see that? Isn't this new line the same as this original problem right here? Isn't this just like this one, except we have a negative 9? So what's the square root of x squared, everyone? X. Square root of negative 9? 3i. Put a plus and a minus sign. Do you see the connection there?
Yeah.
Okay, so that's the goal today. We deal with complex numbers, okay? Breaking them apart by factoring, okay? Cool, here we go. These are the steps. If you're on the video, please pause. Write these down. All right, here we go. Numbers 1 and 2. X squared plus 4. It says factor. What does factor mean, everyone? Break apart. Here we go. So x squared plus 4. Ready? X squared plus 4. It's not difference of squares yet. I can't factor this. But I can rewrite this as in a new identity. Actually, it's going to maintain the same identity. Right? So this isn't x squared plus 4 the same thing as saying x squared minus a negative 4? Right? What's the square root of x squared? X. So you're going to write x and x here. And what's the square root of, oh man, what's the square root of negative 4, everyone? 2i, right? And then you put a plus and minus sign and we're done. Does that make sense? Okay, cool. So that's number 1. Pretty easy, right? Okay. Again, we're talking about identities. X squared plus 4 is the same identity as our answer, and x squared plus 4 is the same identity as this middle line, x squared minus negative 4. Same identity. Does that make sense? Okay, number 2, we got x squared minus, or x to the 4th plus 3x squared minus 4. Okay? This is where things get a little more intense for algebra 2. Okay? Ready? X to the 4th. How many solutions would you have if this was like a solved problem? 4, right? So here I should have 4 factors, okay? That's just, we know that because it's x to the 4th, okay? X to the 4th is kind of scary to deal with, okay? Let me teach you a different way to deal with x to the 4th. Let's just pretend that x to the 4th, we could just pretend that x squared is equal to m. So whenever I see x squared, I'm going to pretend it's m, okay? I'm going to just do that. So x to the 4th, watch this. X to the 4th is the same thing as saying x squared squared, right? Would you all agree with that?
Yes.
Cool. But what did I just say x squared was equal to?
M.
All right, it's up here. X squared is equal to m, right? So I see x squared here. I'm not going to put x squared. I'm going to change x squared to m squared. Okay? Did you all see that?
Yeah.
And then I'm going to bring down the plus 3, and I see x squared again. What did I substitute x squared with? M, right? And then I'm going to bring down minus 4. Isn't this like an Algebra 1 factoring problem? What is this factor to, everyone?
M minus 4.
Uh-huh.
Or wait. No, it's M minus 1.
Everyone, what is it? M?
minus
1 and M plus.
Oh.
It doesn't matter what order. But you're right. M minus 1, M plus 4, M plus 4, and M minus 1. Do you all see that? But is my original problem have x's in it?
No, but that's okay.
It does, right? So should I have m's in it? No. So what did I say m was originally? M was really x squared. So I'm going to change these m's now to back to x squareds, right? And then we got 2 other binomials, right? I could still factor this. Look at number 1. What does x squared plus 4 turn into? What's the square root of x squared?
X.
Good. What's the square root of positive 4?
2i.
2i. Good. Now you're getting it. Okay. What about the second one? What's the square root of x squared?
X.
Good. What's the square root of 1? No, on this one you see there's a minus sign here. This is difference of squares.
1.
So it's 1 and 1. Make sense? Sadala just asked, where did I get m from? I made it up. Okay? I made it up. That's a good question. The reason why is I wanted to simplify it. X to the 4th is scary, so I just pretended like, let's not use x to the 4th. Let's say m is equal to x squared and simplified it. So I could break it apart. Does that make sense? It's a little trick that we have in math, and it's like a useful trick to know how to break things down a little bit more carefully. Okay?
Yeah.
Alright, so I want to hear some talking. Let's start with the ones today. Ones, tell the rest of the group. Actually, let's just have ones talk about number 2. We're only talking about number 2 today. That's it. and then you're going to write down number 2. Ready, set, and go. Number 3, we got x squared plus 81. Okay? Doing this in your notebooks. This one's like number 1. Okay? What is this factor to be? Write it in your iPad so I could see it. I'll give you 30 seconds. Another way to write this is x squared minus negative 81, right? Now it's difference of squares, so it's saying like x plus 9i and x minus 9i. Okay, next one, number 4. Number 4, go. So this turns into, this is like saying 4. This is like saying 4x squared minus a negative 25, right?
Uh-huh.
What's the square root of 4x squared, everyone?
2x.
2x, thank you. What's the square root of negative 25?
5.
No.
Negative 5.
No.
And then 5 plus imaginary 5. 5i. 5i.
You're trying too hard. Okay,
I got
5i.
it
Oh my gosh. Okay. 2x plus 5i and 2x minus 5i. Make sense? Another way to look at this, I want to show you one more way. Ready? So, another way to look at this, let's say it was like 4x squared plus 25 is equal to 0. Remember how I showed you like you could solve and you could subtract 25? And I could divide by 4. Look at this problem here on the side. Look at how it's working out.
You're a fast writer.
Okay, so I want you to know that this is also an identity of our original problem. Or this is the same identity, it means the same thing. You'll see that? Okay, cool. I just want to make sure we're seeing that. This is good. The red one's good. The one that we originally did, that's correct, okay? This is also correct, okay? Again, it's identities. All right, continuing on here, number 5. Okay, this one's going to be like number 2, so let's all work on this one. Look at number 2 on your notes that you just wrote down. You're going to have to pick a letter to substitute with, okay? So, here we go. For those that are confused, eyes on my screen. Some students are confused and they're still staring at their iPads. Okay, eyes up here. Ready? So, I'm going to pick D on this one. It doesn't matter, because what I'm saying is that x squared is equal to D on this problem, so then I pick D because my first name is David, so I'm like, okay, D. It doesn't matter what you pick, okay? And that's it. There's your answer. Okay? When you get here, what does this become? This is like saying, well, we can't factor this, so we know this is like saying x squared minus a negative 16. Square root of x squared is x. Square root of negative 16 is 4i. Good? Is this making sense? Okay. Again, now we're starting to factor imaginary numbers out. Okay, next one, number 6. Number 6, what do you notice about all 3 terms before we even start?
All 3 terms are, they all got an x in there?
They all got an x in there. So now we can factor out an x before we start. So let me help you out with the first step. Okay. And this one is like number 5 now. It's not the same numbers, but it's the same idea, except keep this x on the outside all the way down and then just work on this. Focus on these 3 terms right here. Break these apart, okay? You can go. Number 6. What letter do you want me to use? M, W. What other letters? K. What else? Z. Okay. Does it matter what I use?
And.
No, it doesn't matter. Let me show you how much it doesn't matter. Eyes on my screen. I'm going to use
X.
happy face, okay? X equals happy face plus 5 happy face minus 36, because I told myself that 1 happy face is equal to x squared, okay? Does that make sense?
Yeah.
Does it matter what you use? No, it's kind of tedious to draw a happy face, so that's why I use the letter, okay? Alright, so I could factor this, right? So here we go. This is like saying x times x plus 9, happy face plus 9 times happy face minus 4. Is this making sense? But I have an answer with a happy face. Is my problem supposed to have happy faces in it?
You gotta put it back to
No,
x
what does
squared.
happy face turn into?
X squared.
No, not just x.
X squared.
X squared, right? So I got x times x squared plus 9 times x squared minus 4, right? Okay, so this first one, is this difference of squares right now? Is this difference of squares?
No, not yet. We have to simplify.
We have to subtract a negative 9. So it's like I'm going to have x times x minus 3i plus 3i. And then I got x plus 2 and x minus 2.
Why come the i's never go in there?
Yeah, I got a question. Why don't the i's go in this last one? It's already a negative. It's already a negative. Good. Exactly. Who raise your hand if you put too high here at one point?
That was
Okay.
me. I'll be honest.
It was somebody.
It was
That's
me.
right.
I did do that.
Okay, that's a good question. Did y'all see why you can't use eyes all the time? Y'all see that?
Yeah, I guess so.
Okay, thank you. All right, good. That's your answer. All right. Now, look at the original problem, everyone. Do y'all see the original problem?
Yeah.
What's the exponent on the original problem? What's the largest exponent?
X to the fourth power. Fifth power. Oh no. I'm looking at my paper.
Fifth power. Good. So how many
What
factors did I have? 5. Good. So remember, what if this was a solved problem? Let me just extend it one more time. Eyes on my screen. I want to show you something that will start making a connection in the future. So how many answers was I supposed to have? How many solutions am I supposed to have if this was solved? 5, right? So check this out. A solved problem would make it turn into like equal to 0. Here we go. Look up down here. I just added a 0 equal to 0. I draw a factoring. I'm going to bring that equal to 0 down here. Remember the zero product property? Check this out. All of these become their own factors. X is equal to 0. X plus 3i is equal to 0. Subtract 3i, so x is equal to negative 3i. There's an answer. X plus minus 3i is equal to 0. Add 3i. There's an answer.
Whoa.
X plus 2 is equal to 0, so x is equal to negative 2. X minus 2 is equal to 0, so x is equal to 2. How many answers did I have? How many solutions?
That's 5.
Good. 5 of them. Does that make sense? How many real ones are there? How many real solutions are there?
There's only going to be 3 real solutions.
How many complex solutions are there?
2.
2. Good. Does that make sense?
Yes. He's just said good, yeah.
Okay, now go to Desmos and I want you to plug this in. I want you to plug in the original problem. Everyone's going to Desmos. You're plugging this in, okay?
Yeah, no. No.
So put x to the 5th plus 5x cubed plus or minus 36x.